Hello everyone, my name is Andrew Klein. Welcome to my shop. Now I really thought by now I'd be getting into another furniture project, but it just so happens that I was struck with inspiration to do something that I've been kind of kicking around in my mind for quite a while but didn't have a good solution to. And that's to build a really interesting, cool, shop-made end vise. So the problem with my current end vise, this is probably the cheapest way to go for an end vise you can purchase. It's just a single screw, and the issues here, first of all, there's no quick release. It racks very badly if you clamp a piece on one side, so I have this deal to balance out the clamping pressure, which is, you know, it works, but it's kind of an irritating solution. And there's also an obstruction in the middle, so you can't get, even with this, you can't get very good clamping pressure on a board that you're trying to hold, like this, say. So as far as end vises purchase go, really the next step up from this would be one of the twin screw vises that doesn't have a chain going in between, so you have to rotate each of the screws independently, which I've never used one, but I would have to imagine that it gets a bit troublesome if you have a piece that you need to place in. You'd have to tighten them up so that the piece barely fits in, then tighten one as the vise racks and tighten the other, and kind of go back and forth. So not terribly convenient either. That's something that would be fairly easy to do with a shop solution, but it really wasn't interesting enough for me to tackle. The next step up from that would be a twin screw vise that has the chain linkage in between, so that you only turn one of the screws and the other one's turned by the linkage. Issues with that, those are getting to be pretty expensive. Lie-Nielsen and Veritas both, I think, make decent ones, but they're between $200 and $300. I don't know exactly. You're getting to spend a lot of money there. They're not quick release, so if you want to use them to clamp a thick piece, or if you're using dogs to hold a board like this, you're going to have to crank that out quite a bit, and you're probably also going to want to drill a lot of dog holes, which is kind of irritating when you're building the bench. Having more dogs would prevent you from needing to screw it in and out so far. So that's the issue there. And then to my knowledge, the ultimate end vise costs close to $400. It's a specialty thing. I really haven't seen any reviews on it, but it has kind of the ultimate functionality. It's non-racking. It actuates when you just turn one of the, it's not even screws, it's some kind of a clamping mechanism on just a steel rod. And it has an integral quick release, and by that I mean the loosening mechanism undoes the quick release. So you loosen it and it can slide free, and you push it up against the piece, you tighten it, and that tightening motion activates the, deactivates the quick release, so now it's clamping without any separate switch or lever that you're actuating in order to work the quick release. So that's really the ultimate. I think I've come up with a shop solution that has that same functionality and is built with material that you can find in a home center. It's not perfect. This is still a prototype. Still got some work to do on it, but enough yapping. I'll show you what it looks like. Okay, so here it is. I'm calling this the cable vise because it uses a cable to put the pressure on the workpiece. But before I get into the details here, let me just explain what you're looking at. So this is obviously a prototype. This piece would represent the end cap end piece that's put on the end of the bench, similar to this piece here on my workbench. That's the analogous piece on the simulation. So the workbench top is missing and would be in this plane right here. And these are the runners that hold the vise. So, and then over here I have just a very simple crank to tighten the cable that's on a double reduction pulley to give me some mechanical advantage. So what happens as I turn this and tighten up the cable, the first thing that happens is that the tension at the end of these long runners pulls them together and jams them against this, which is simulating either legs of the bench or a piece that's attached to the underside of the top. A lot of ways to handle that. The point is a piece of wood to jam these two against. It's anchored to the bench so that these become immobile once any kind of tension is put on this cable, and you can see them move. Just because of all the torque, even these 4x4 pieces are coming together, are bending and preventing them from pulling forward. Okay, so what else? So once these are locked in place, they can't move anymore where they initially start out being able to slide. I made this pulley a little bit short. It could come out if I had set it up a little bit differently. Anyway, prototype, bear with me. Once these are locked in place, the chop, the front of the vise, also needs to be able to move relative to these pieces to clamp whatever it is that you're working on. So they're on a pivot. They start out at 90 degrees, but they can angle forward. If you clamp a piece, put it in the jaw. Let me get some clamps on this to hold it in place. Okay, so free movement when the cables are loose. Put the piece in, push the jaw shut. Cable pinches the two runners, and then, since you have the cables attached to this chop, pulls it tightly against this piece. And you can see it's not going anywhere. I'm shaking this whole bench. It weighs like 300 pounds. So it's non-racking because this chop is not going to want to twist. It's anchored at both sides. So if I put this in, very little racking. Okay, so now we come to the problem with the prototype. When there's tension on this rope, there's torque on the handle, and right now there's not enough friction or weight to keep it in place. Now I think that I have a fairly decent plan of how to modify the shop-made setup so that it doesn't spin free like you just saw. What I do is a combination of making this a bit heavier so that it has some natural weight to stay in place, adding a little bit of internal friction because right now there's just almost none, and then also doing a quadruple reduction pulley setup instead of a double reduction. That'll cut the amount of torque on this shaft in half. I believe with a combination of those and some fiddling around, I can get this to the point where it doesn't spin free. The other option is a lot simpler but less elegant, and that is to buy a worm gear boat winch for $60 on Amazon. That has the mechanical advantage built in. A worm gear is not going to spin free. The torque on this wheel is never going to back rotate that worm gear. So you could simply mount this right here and hook the cable up to it and be finished. I'm going to try that out, but I'm very confident that it's going to work. So really, I'm trying to gauge the interest and using this video to do so. I'm really curious to hear what you think of the solution of just keeping plugging away at the shop solution, or the boat winch, or whether or not this whole thing is just a silly idea, or if it's really as cool as I think it is. So please let me know. I'll be curious to hear the thoughts and the reaction on this one. I hope you found it interesting, and thanks for watching.